Well, hello everyone. My name is Alan Siebenthaler. I'm the Marketing and Territory Manager at Hamilton Kent, and welcome to our latest webinar, Connecting the Pipes. So first off, I wanted to share just briefly about Hamilton Kent for those of you who may not know who we are. We're one of North America's leading suppliers of rubber gaskets and flexible connectors for the underground infrastructure. We have over 70 years of firsthand experience supplying products for water and sewer projects for cities, municipalities, and other infrastructure owners. We employ a sizable and experienced technical department, which makes itself available to help customers and consulting engineers in cities with regards to our product lines and as well as the projects where they're used. Hamilton Kent manufactures a broad variety pardon me, of rubber sealing products in 2 ISO 9001 and 14001 certified plants. One of those is in Winchester, Tennessee, and the other is in Toronto, Ontario. This reflects not only our commitment to quality, but also to the safety of our personnel as well as environmental awareness. So a little bit about the presentation. Here are the topics I want to cover, like what are flexible connectors? What is their importance to you, for those of you on the call today? What different types are available? How are they installed? I've got a couple of videos that talk about installation or demonstrate installation. And then, how do you select what's best for you? And that could be different criteria as far as application or the requirements on the project. So first of all, since early development of towns and cities, conduits have been used for transportation of water, industrial waste, sewage, you name it. And with such transportation, builders found it much easier to utilize what we now call manholes and maintenance holes to provide connections between different lines, so they could run them underground instead of on the surface. So you can see in this example from ancient Rome, various openings in what we call the manhole in this image, much like you'll find today. As I'm sure that most of you on this webinar know, a typical manhole or a maintenance hole is made up of most of these components. So you can see all the way from the top with the castings going down to the adjusting rings or grade rings. Then below that you have the cones, and then below that you have different risers or barrels. And then at the very bottom is the base, and that's what we're really be talking mostly about. And that's because that's where you're typically going to have most of your pipe coming into a manhole structure, that's your base. Not always, but frequently. And you can see even in this drawing, which is a kind of a low resolution drawing, so my apologies for that. But you can see the connections that are coming in there. So let's talk about just basically creating the holes in a manhole for those pipe to come in. So a lot of precast concrete producers utilize coring machines for cutting those holes in the structures needed for those connections. And this allows them to maintain a stock of manhole bases and then customize them as needed for orders rather quickly. So that's a positive. They can basically make a structure that's needed very, very quickly for a contractor. But the cons on this, I guess the downside of doing this is they must maintain a coring machine, which is a very expensive piece of equipment, and a few different sizes of coring bits to allow for different sizes of pipes, which also can be very expensive. And number two, they're essentially wasting the concrete removed from the structure. So when they core that hole out of that manhole or square structure, they're going to be just throwing that concrete away and the reinforcement that's in it. So they're essentially wasting that material, which is not costly, but does add up over time. And not to mention the fact they have to dispose of that in some way. But there's also a lot of time and equipment cost for doing this type of coring. And here you can see the different types of coring bits that are used. So those can get quite expensive, especially if buying a brand new set. So now if you talk about an alternative to this, some precast plants use what are called hole formers. Essentially, it's just it can be made out of a variety of different products. A lot of them are fiberglass. I've seen some companies that use styrofoam. Different types of ways to do this, but basically what it helps to do is it saves on the cost of the concrete and the reinforcement that would go into that manhole in that hole. But the cons of it is that you must know the whole location exactly before the structure is cast. You have to know exactly what the what the size is going to be, and this delays the delivery process somewhat to a contractor. So some contractors will not be very timely with how quickly they order their structures, and so if it's a custom structure, then that will mean that they have to cast the structure very quickly, and sometimes that's not possible. And while the hole formers are reusable, they are still expensive. They can be broken, and they do take labor in order to secure it to the inside of the formwork. So there are some cons and downsides to a hole former as well. This is another method I've seen, and this is at a dry cast plant, and this is how they were setting up for openings for the job site. This process is labor intensive, as each of these openings is created by someone basically poking the concrete away from that wire mesh in the dimensions that they are required for that job or for that project. It also wastes a lot of concrete and requires a lot of cleanup. So, in my opinion, not a very efficient method either. But then there are also some risk of affecting the structural integrity of the structure if the concrete is too green. So if they start poking that out and that concrete starts to shift or fall, then that's going to cause a big problem. However, when shipping it, it does make that structure, it helps to maintain its strength overall because it has that reinforcement consistently running through it. And it makes it very easy for the contractor at the job site to basically just cut that wire out and create the opening. But this is obviously not going to be a very clean hole. It's not going to be very smooth or consistent, so definitely not intended for a rubber connection. So this is a picture that we use pretty frequently, and the one thing I noticed right off the bat is a guy smiling, which is probably not realistic for a guy working in the trench. So probably an actor or a model. But anyway, this is what we see quite often in a stormwater application. Hopefully this is not going to be something you'll see in a sanitary application. And the reason being is that we just do not think that this is a very permanent solution. You can see that the pipe going into the structure is going to be a flexible plastic pipe. And if there's any type of differential load that's put onto that pipe versus onto that manhole, or if there's any type of deflection in that pipe anywhere near that manhole, more than likely that mortar, those blocks that are in there, there's going to be some shifting inside that and likely cracking, and that's just going to create an opportunity for a leak. And while a small leak in a stormwater application may not seem like a big deal, we'll talk about here in a little bit why that could be. This is at a job site I visited not long ago, and this is how they're trying to get around it. They're putting a rather large concrete or mortar shell around that connection with the manhole, and you can see, especially on the left-hand side over here, there's a pretty big lump there where that pipe is, and that's where they've really gone overboard, I think, with trying to put a connection around it, trying to strengthen that connection. And a little bit same thing on the right-hand side, not so much around this one. But regardless, I mean, you're talking about putting non-reinforced concrete, which has a chance of cracking, and anytime there's a chance of cracking, anytime that you're putting a load on that pipe, something could happen, and that could cause a slight opening. So just to kind of go back to the basics, I mean, if you think about the underground infrastructure of a typical city, you're going to have your water coming in from a reservoir into your water system. You can see the blue line here that is feeding into these homes. And then you have, in some cases, cities have just a dedicated sanitary line, and so you have like the home on the right where you have the sanitary is all going down into a sanitary sewer. In some cases, a lot of cities will use a combined sewer system, and so they have the sewer as well as the roof drain, they're all going into a combined sewer. And then you might have a separate sewer, storm sewer. So you can see that those are all just shown here, and it's just to kind of give you an idea as to what we're looking at here. So sealing a sewer line, you can see here, these are all the different types of sealing systems. Everything from the very top of the system, so you have a watertight manhole frame or chimney seals, a lot of different products there. Different types of pipe gaskets, as well as for their different joints, as well as manhole joint gaskets. And then you have the different connectors. You have saddle connectors, you have boot connectors, you have casting connectors, and that's what we're really going to be focusing on today. And so these are all different products that that we're involved in and are available on the market. So here's just a sampling of some various types of rubber connectors. Some are more intended for a casting connection. So this one right here, you can see it has a flange that has some pretty beefy section around the outside of it that goes in the concrete, and that gets cast in, and so that just creates extra strength in holding that into the concrete. And here are a couple of connectors that are actually cast in already into a manhole. This one is one type of connector, and then this is a kind of like a boot connector. And then you also have connectors that are what we call mechanically installed. And so this picture on the bottom right is a mechanically installed connector, and we'll show a little bit more about that here in a minute. And then up here is the same type of thing. It's a connector that's basically a push fit connector into a manhole. There's different types of requirements that jobs have, and so there's different types of abilities that these gaskets or these connectors have. So some of them will offer more deflection than others. Maybe they'll offer 5, 6, 7 degrees of deflection of the pipe coming in. Some will have greater strength in what they're able to withstand as far as water tightness. So your typical connector is going to be 13 psi, but then there are some that are more meant for a soil tight type connection, and those will be a 6 psi connector. And while we're talking about water tightness, the industry standard for watertight connections is ASTM C923, and so that's when you have a specification that's going to call for watertight connections. That's the standard that most people are going to refer to. What that is what it's requiring is for straight alignment of pipe coming into that connector to be able to withstand 13 psi of water pressure for 10 minutes. And in a deflected position, so that pipe is actually deflected 7 degrees, and I'll have a picture in a minute to talk more about this, and be able to withstand 10 psi of water pressure for up to 10 minutes. And then shear loading, that's where you're putting pressure on the whole pipe downward, so that it's more of a shear pressure, a shear load, and it's supposed to do the same thing, 10 psi for 10 minutes. So, as I mentioned here, if water tightness is important for your project, for your product, then we certainly suggest that you require C923. And as I mentioned a minute ago, this is some testing. This is actually a manhole that we have at our plant that we do our testing for our own boots. And you can see that we've kind of have an elaborate structure set up here, but we have these bands that go around it just to offer more structural strength to the manhole, just because we're pressurizing the manhole to 13 psi, which may not sound like a lot, but that's a lot of pressure that manholes are not designed typically to withstand. Unless you ask for that, that's not the way they're going to be designed. So we have that extra strength there. You can see the boot here with the pipe running into it, and this would be a pipe in straight alignment, so it's going straight into that boot connector. Now over here on the right-hand side, you can see that this is at a different testing apparatus we have in our Toronto plant, and you can see that this jack right here is set up to deflect the pipe. So what it does is it's going to be putting upward pressure on the pipe in order to deflect it 7 degrees. And it's in this picture on the left, it's not set up that way yet, but that is what this apparatus is also intended to do. So this is the type of testing that's required for any type of connector that's supposed to meet C923. So why watertight? Quite simply, I mean, as water goes into the ground, between pavement, around a manhole frame, however it gets into the ground underneath and around a manhole, if there's a place for water to go to flow into a manhole or pipeline, that soil is going to be the fines are going to slowly be pulled into that pipeline. I say slowly, but it could be quickly as well, depending on how big that opening is. But over time, this erosion of the soil can cause the pavement to crack and sink, resulting in consistent repair problems and possibly to large failures. So you can see some pictures there on the top right there of some, obviously some really bad manhole problems. A street collapse like the one shown in the bottom right there, it was in Chicago a few years ago, and something like that would be very costly and potentially very dangerous. But there is an additional issue here, and that is that the fines that erode from around the manhole structure and into that pipeline will eventually cut down on the capacity of that line to convey sanitary or stormwater. And so this could lead to additional costs of repairs of having to clean out those pipelines. So what needs to be watertight? Well, in our opinion, if we're looking at the long-term durability and lifespan of our underground infrastructure, and by saying underground infrastructure, I mean water, stormwater, and sanitary collection systems and conveyance systems, then our opinion is that everything needs to be watertight. If everything is kept watertight, then that is going to make it last much longer, as well as the infrastructure that's above it is going to last longer because you're not going to have those leaks. So let's talk about the different types of connectors. I've mentioned briefly about mechanically installed connectors. So those are meant for a cored or formed hole. As I mentioned before, they're the coring machine, or you can also use a hole former. So it's meant for those types of holes. It's installed not right after, but it's installed after the precaster has cast the manhole. So it could be within a couple days. It could be just whenever it's ready to ship out to the job site. But it's going to be installed at the precaster's facility before it goes out to the job site. There's various designs and capabilities, as we have kind of mentioned. There's different types of sizes, different types of configurations and methods of installing them, and just whatever is needed at the job site. Frequently, they're referred to as a boot. I think I've already mentioned boot, but a lot of times they're just referred to as a boot connector or just a boot. Most of them are going to be watertight, and watertight up to at least 6 psi, which we call soil tight, but many of them are also going to be up to 13 psi, which we consider strictly watertight. They're usually made out of a UV-resistant EPDM rubber, and the reason for this is, number one is it has good physical properties, but number two is that it's, if they were installed at a precaster's facility and kept out in the field out in the plant for, say, for a few weeks or something like that, or if it goes to a job site and sits at a job site for a few weeks, we're not worried about the deterioration of that rubber because of the UV, it has that UV resistance already. So no issues with ozone or UV rays. Also available in oil-resistant materials. So if you have basically any type of potential exposure to oils or fuels or something like that, then we do have boots connectors that are available in that material, which can withstand or has very good resistance to it. So here is a typical mechanically installed boot connector. You can see the dimensions here. The A dimension that's on the far right is going to be the dimension that's most important for the hole size in the manhole. And then the C size is the other most important consideration or dimension, and that's because that's where the pipe is going to be coming into the boot connector. So what are the components of a mechanically installed boot? You can see here that there are really just 4 components. Number one is the shield. That's over to the left-hand side. That usually runs underneath the hoop just to protect the sleeve portion of the boot from being cut or punctured by the hoop as it's being tightened. The hoop is going to be the part that is tightened in various ways, and I'll show that here in a minute how that works. But the hoop is the part that expands within that sleeve to tighten it up against the hole that's going to be installed in. Then you have the sleeve, which is the black rubber part there. Again, that can be available in EPDM standard, but also can be available in nitrile rubber to make it oil resistant. And then you have the clamp, which goes around the end of that that sleeve goes on the outside part here in order to tighten it down against the pipe. So really a fairly simple product overall. And this just demonstrates a little more plainly as to how it works. You can see that this is the inside of the manhole structure here, and you have the wall of the manhole, and this is the hole. And so you have that boot that has been installed. And inside this, you can just kind of make out there's a little bit of a design there that shows that that's the hoop that's tightened up against that concrete structure. And then on the outside here, you have the band that goes on the outside of it to tighten it up against the pipe. So a mechanically installed boot that has a ratchet style of tightening mechanism, and there are a variety of different styles out there that different producers of boots have, but this is one that we have, and it's fairly popular. And it just takes a ratchet in order to tighten that nut that's on the outside. And what that does is it creates force that goes out to the right and to the left where those red arrows are on the hoop, and then tightens it up against the inside of that concrete hole. It's very easy to install, so that's a positive. The thing that we find that are probably the most problematic is that they can be over tightened. So we definitely recommend using a torque limiting ratchet, but then just using that covers it, I think. And then the good thing about it, I guess, is that it can be adjusted in the field, but it also is maybe a downside is that it can be adjusted in the field. And what I mean by that is that if you have a contractor who has a pipe that's coming in at an angle that he wasn't expecting into the manhole, and he wants to make an adjustment to that boot, he can loosen that boot up, twist it a little bit, and then so it meets in with that pipe, and then tighten it back down. Well, what you're relying on him to do is, number one, is that he's putting it back into that hole correctly so that it's going to seal well at the hole, but then also that he's tightening it down enough to make sure that it's going to be tight. So that's there is some risk and reward to using a connector of this type, but it is the most popular type that we see. I'm going to show a short video here. It starts off with he's wiping down the inside of the hole, which is important. We recommend that. So you wipe it down just so there's no debris, and then you put the connector in and line it up so that it's basically so that hoop is roughly about the middle of the manhole wall. And once you have that straight, then from the inside of the manhole or from outside and reaching through, you can then tighten that into place. So now he had chose to go inside to do it, but again, you could do it from the outside and reaching through, and then just showing him tightening it down some more from the inside. So again, this you can see he's using a ratchet style, and it just, as he's tightening up, it just tightens that hoop on the inside of that boot. This is another type of connector from mechanically installed boot. You can see on the right-hand side is a jack that has 2 feet. They're kind of gold-colored. Those feet fit into notches that you can see one of them just on the right-hand side of that picture of the hoop, and then the other one is off to the left. They fit into those, and then as the jack is tightened, then it expands that hoop out, and then there's notches. There's little notches in the hoop, and as it tightens, there's a little tab here that snaps into place, and once you've reached the proper torque on it, then you're able to release it, and it's going to lock in place. So the one thing that's good about this one is that it can't be messed with in the field, so that if there's any type of anything the contractor wants to try to do, he's not going to be able to do that without the precaster knowing about it. The downside is that these jacks are relatively expensive, and they do require occasional maintenance. And it's something that if you do need to make an adjustment in the field, then it means you have to take that jack out to the field in order to make that adjustment. Another type of connector we have is this one requires a jack that actually it sits in the bottom side of the hoop, and then you jack it into place, and you can see in this left-hand picture, it puts pressure going up into this V, and as that V starts to expand out, as it's pressurized, then it's going to be putting pressure to the right and to the left on the hoop to tighten it into place. So the good thing about this is it can't be altered in the field, and it's very effective, and it's very easy to install in a precast plant. The bad thing is that you literally have to destroy the hoop in order to get it out, and in order to remove the boot. So, you know, there is a little bit of good and bad with this type of connector. As I mentioned before, there are other types of designs, and this one is one that's simply a push fit. You push it into a hole, so you can see the connector over to the left-hand side, and then on the middle picture is installed in the hole. It's going to be a fairly tight fit, but it's something you can hammer it in. And then on the right-hand side, as that pipe has gone in, what it does is it's a little bit bigger than the actual connector itself, and so it puts a little bit of outward pressure on that connector, and then thus creating an even tighter fit with the concrete structure. So it is a good compression fit type of connection. Meets ASTM C1478, which is up to 6 psi of water pressure. So it's a good soil tight type of connector it's easy to install in the plant and easy to use in the field. Casting connectors. Now let's talk about connectors that are actually cast into the concrete. There are a big variety of connectors, and I think I showed you a few of them in an earlier picture. They're very watertight along the perimeter, and unlike a mechanical connector, you're relying on making sure that's tight on that inside the diameter of that hole in the concrete. With a casting connector, you don't have to worry about that because the connector is inside the concrete. Again, it's made out of UV resistant rubber, so that it can sit out in a precast yard or at the job site for a number of weeks and not have any type of deterioration. But there are other options available. Again, you can also get these manufactured out of a nitrile rubber in order to make it oil resistant. They do require mandrels during the structure's production. So when a precaster is producing a manhole, they do require a mandrel. And what that mandrel does is it, number one, protects or holds back the concrete from running in and all over the connection. So it holds the concrete in place to make that hole. But then I can't remember what else I was going to say, but anyway, it's manufactured out of a variety of different types of materials. We've seen fiberglass, steel is very popular for smaller ones. It requires much more precise installation. So when a precaster it comes time to cast it, they have to be very careful about making sure they have the exact position, because once the connector is cast in, there's just no changing it. Now they could core a hole there, and if they need to adjust the size and put a boot connector in there, but it is something that you do require much more precise installation. And then field repair replacement can be problematic. There are methods you can use to do some field repair on some of them, but replacement can be problematic. Just other than maybe coring a hole and putting in a boot connector. So here's a cast-in boot. As I mentioned before, it does require a mandrel. You can see over here in the right-hand picture that this mandrel is the steel part right there that's connected to the formwork right there. And you can see what I was talking about before, that some of that rubber is sticking outside of that mandrel, and that's what will be cast into the concrete to really hold it in place. And then down below is a picture that shows the boot in the manhole after it's been cast. So this boot like this has excellent sealing capability, excellent deflection capability, so it's going to be able to withstand the pipe coming in at an angle. And one thing that's also nice about it is that it's a familiar configuration. So when you send a structure like this out to the field, then it's not really much different at all than just a normal, like a mechanically installed boot. So they'll see this and they'll think, oh, okay, it's just a boot, and they just need to put a band on it, tighten it down, it's good to go. And one thing we have seen is that some precasters elect to do is that they have a common size that is almost always going to be in their boots, and maybe it's like an 8-inch, like for instance, probably 8-inch PVC pipe. So what they elect to do is they cast one of these in every base, and what that allows them to do then is avoid either coring or using a hole former to create that, and the boot's already there, then they can just come back in and core in whatever other holes they need to. And so that just saves them a few dollars in concrete, and it saves them a little bit of time in installation. And so it's just been helpful to them in that regard. Another type of casting connector, again, requires a mandrel. You can see up in the top picture, there's the connector with a mandrel. Excellent sealing just because of being cast in, and deflection, the same thing. This type of connector does not require a clamp on it, so it's actually cast with the part that protrudes from the connector actually is cast in toward the inside of the manhole, and then the pipe is pressed through. And because this section right here where the pipe comes through is very, very thick, very I call it beefy, but it's a big, almost like a big donut, rubber donut at the end. It's so tight that as a pipe comes through, it creates a very nice watertight seal. So it's very simple installation. You just have to make sure you prep the pipe well. There's no clamping, but it's only for smaller size pipe. There are only a few sizes of this, so it's not for a bigger pipe. Another type of casting connector, and this is going to be for situations where it's a larger pipe. It can be for a small pipe, but a lot of times it's used for a little bit larger pipe. It also requires a mandrel. You can see here this is a fiberglass mandrel in both these pictures. And you can see the hole in the middle here. This is where you can put a magnet in to hold it in place. And almost every mandrel you can get has the ability to use a magnet to attach it to the formwork. There are some precasters that elect to bolt them to their forms, but a lot of them don't like to do that because they just don't want to drill holes in their formwork, which can be costly to repair or fix. Installation care is very critical, is just making sure that you put it in exactly where it's supposed to be, and this is where the QC manager or the QC technician really becomes important, because they come through and they measure everything before it gets poured to make sure that those connections are all in the right place. You can have it manufactured virtually any size. Really the only limitation is the mandrel. You just have to get a special mandrel made for unusual sizes. But if you want a mandrel that's going to fit a piece of 36-inch concrete pipe, that's available. It's just going to be a very big mandrel, heavy mandrel, and a very big connector. It is C923, so it's very reliable. And then there is some minor on-site repair that you can do in order if there is any type of issue during installation. Here's a short video that we shot at one of our customers' locations, and you can see initially that he's tightening this mandrel. So I'll show that here in just a second. Here's a mandrel right here that's has a connector installed in it, but over to the left-hand side you can see that there's a mandrel that doesn't have a connector in it. So you can see the two pieces that come together in order to basically squeeze against that rubber. So let me get this video started here, and you can see that he's tightening it down so that the mandrel is going to be nice and tight. And then once it's tight and it's ready to go, then you just get it, put it on the form, and he's going to swivel into place, and it's going to fit nicely up against the core of that formwork. Then the concrete's poured, and then the next day they're stripping away the formwork, and you can see that all you can really see at this point is the mandrel, because the rest of it is inside that mandrel. So they loosen up the outer jacket of that mandrel, and then that piece comes out. And then there's still the inner piece. So once the inner piece of that mandrel is pulled out, then you can see the connector is in that hole, and that's all you can see. And then they decided to do some testing, and this is something that we encourage. You don't have to set it up exactly like this, but this is how they did it. They stacked several manhole risers on top of a base, and then they put the pipe in through the mandrel, and then they can apply 13 psi of water pressure just by filling up that stack of manholes. Okay, and then here's another type of casting connector. This one is again a stormwater type connector, one that can be used for catch basins or for other types of structures that you just need a 6 psi type of watertight connection. Again, uses a mandrel. You can see in the bottom left-hand picture that there's a mandrel that they use for that, and then to the right is the final product. So it's really fairly simple to install at the plant, and then it's very easy for the pipe installation as well. So selecting a connector, and basically we're looking at this from two different perspectives. One would be the precasters, and that's going to come down to a few things. One is economics. I mean, what makes most sense financially for the plant? If you're going to use a casting connector, there's going to be investment in mandrels, but you're also going to save on some of the labor to install a mechanically installed boot. You're going to save in some of the concrete that could be thrown away because you're coring instead. And vice versa, it could be, instead of coring, there's going to be other alternatives. So anyway, it's going to come down to financially what makes most sense for the precaster. Sometimes it's going to be a long-term solution. What's going to be 10 years down the road, is our investment going to pay for itself? In some cases, they have to make more of a short-term solution or some short-term decision. What's easiest to use? I mean, I've kind of gone through the process that they have to go through in different types of connectors. So which one is going to be easiest for them? Sometimes they find that just using a boot connector is easiest. In some cases, some plants, they love casting connectors, and that's all they use. So it just comes down to what the personnel is capable of doing and what management decides is going to be best for them. In some cases, it could be a competitive advantage that nobody in their area is manufacturing using a casting connector, and they demonstrate it to contractors, and the contractors see how easy it is, and then they switch over to that, and then so that precaster has a competitive advantage initially by having that product available. And then working with suppliers, what do suppliers like Hamilton Kent have to offer that's going to be a good solution for them? Then from the specifiers and municipality side, really I think the most critical things are going to be performance, obviously. What's going to perform well in the field, what's going to give them long-term strength and durability, and then what kind of requirement do you want to have? Do you want to have a 13 PSI type requirement or a 6 PSI okay? Life cycle cost, I mean, it's, what's going to be the return on investment for requiring that precasters start supplying a watertight connection for stormwater, and there is going to be some type of requirement there. So what's going to be the payback on that? And then working with the precasters and suppliers, what is going to be what's going to be something that they can supply that is going to be helpful to you as a city. So here's just a couple of pieces of information, I think, for pipe installation that I think are important for you to look at and consider. One is to make sure that the pipe is tapered and deburred. You can see over to the right-hand side, the top picture, it's a concrete pipe, and you can see that they're using a saw at the job site to put a taper on that pipe. And then the second picture down, they're taking a piece of reinforcement and they're deburring. There's a little bit of a seam right there that's showing up on the concrete pipe, so they're deburring that just to make sure that the pipe is very smooth, and so that once it's installed into the connector, that there's no reason for that connector to either one be torn or to have a reason or have an ability for a leak. Then they lube the connector very well and the pipe as well. And then you carefully insert the pipe into the connector, and you can see the bottom picture, that's what they're doing. They have the base is elevated, and they're going to slide that over the pipe very carefully by keeping it elevated like that. Other application or other times when you're installing it, I guess once you get the base set, then you need to install the pipe on the other side. You can use either a pry bar, or sometimes a piece of machinery can be used to push that pipe in from the other side. And then for testing, you can use either vacuum testing or hydrostatic testing. If you're able to block off that line and do testing, that is highly recommended. You need to make sure that you have pipe stubs that are secured inside any types of openings that you would have that don't have the pipeline included in it. Okay, now for the testing of the manholes, as I mentioned before, you can use vacuum or hydrostatic testing. And this is highly recommended, especially for sanitary sewer. If you have a job site requirement that something has to be watertight, then it is highly recommended to make sure that you test it at least a certain frequency. Say you test 1 out of every 5 or 1 out of every 10 or whatever it's going to be, but you have some type of testing you're doing just to ensure that you have water tightness. You should also, if you're going to have a requirement for water tightness, is have the precasters perform the test in the plant and then document it. There are some plant certification programs that ask for this, and a lot of plants are very used to doing the testing and then documenting that, and so that's just something else that we would recommend. And then do the testing according to ASTM C923. I think I've covered that next bullet point. So it's then just ASTM C1244, just pulling a vacuum, and then what the requirement is there, time to drop down to 9 inches. So there's going to be a chart that provides a time allowance for that, depending on the size of the manhole, size of the pipe, and everything else. But that would be another resource for you. So just to kind of summarize here, I mean, connectors are a critical piece of the equation for system performance and the lifespan of infrastructure. As I mentioned, if you have a watertight infrastructure, then that's going to be much more durable for a much longer lifetime. And flexible connectors are such a critical part of that. I've gone through some of the various types there are and some of the benefits and some of the weaknesses that each one has. Certainly each one does have those, and it's just going to come down to your supplier, the precaster, the city with their requirements, what was going to be best for each. But we do encourage you to partner with the precasters and partner with the manufacturers if you're a city or a municipal engineer, to partner with them and find out what are they capable of producing and what are they comfortable with, and those are going to be key components. And then, as I mentioned just a moment ago, associations are a great resource. I mean, the National Precast Concrete Association has some great tools. They have a really good plant certification program, and some state DOTs already require that program for suppliers. So there's a lot of plants out there that have that certification. So we definitely encourage you to work with the associations as well. So that wraps it up at this point. If you have any questions, certainly like for you to submit those again over in the menu bar, the GoToWebinar menu bar. You can enter those into the question box and submit those, and we'll take those here in just a minute. And in the meantime, while you might be doing that, just wanted to let you know that if you would like a PDH, a Professional Development Hour certificate, for your time on this webinar, just go ahead and email me, or you can call the number there. That's our office number, but I think the best way would be to go ahead and email me and tell me that you'd like that certificate, and I'll get that to you here in a couple days. Okay, well, one question that came through is size of connectors, and I think I kind of covered this briefly. For the mechanically installed connectors, there are some companies that manufacture boot connectors up to very large types of pipes, but then others, like for Hamilton Kent, we only go up to a smaller size, just because we think cast-in connectors are a much better product for large pipe. But definitely check with the precaster what they have the capability of producing, and precasters, we suggest that you talk to suppliers like us. To see what we have the capability of offering to you guys. But there is a pretty broad spectrum out there depending on who you work with. Okay, I'm not seeing any more questions coming through, but we do encourage you to visit our website if you have any questions. We do encourage you to follow us on Twitter and Facebook and LinkedIn. We do provide a lot of information throughout, pretty much almost daily. Information is being posted on all those, and it's a good way to be kept abreast of new products, new developments, projects, and case studies, and things like that. And feel free to contact me directly if you have any questions as well. Again, we do expect to have this webinar available online here in the next few days, and you will get an email follow-up from us. And again, make sure you email me if you have any, if you'd like a PDH certificate. But have a great day, and don't forget to properly connect those pipes, and we'll speak to you again soon. Take care.